you to the Great Lakes Levels 101 program. If you don't know me, Dan O'Keefe with MSU Extension and the Michigan Sea Grant College program, and I'm housed right in this building downstairs. But a lot of people came together to make this program happen tonight. I want to thank our speakers, Mark Breederland, also with Michigan Sea Grant, who is my counterpart up in Traverse City, Keith Kompolowitz with the U.S. Army Corps of Engineers, and also Jeff Fritzma with the U.S. Army Corps of Engineers, and Louis Saldivia, who will round out our panel of speakers for today. And I also want to thank Kelly Gower with the Macatawa Area Coordinating Council, and Becky Huttinga of the Ottawa Conservation District for helping with the refreshments and organizing the registration process for today. So we really have the program broken up into a couple sections. First of all, you'll see some pictures from around the area, the fishing dock on Lake Macatawa, where the Macatawa River comes in, that's high and dry right now, and a lot of other scenes from around the area that really illustrate just how low the water levels are. So today's program is going to go into some of the science behind how water levels in the Great Lakes rise and fall. We're going to talk first about the natural cycles and about where we are at with those and some of the factors that go into driving the lake level cycles and the low levels that we're seeing now. So the first session really will be on the background with water levels, science with Mark Breederland giving an introduction, and that being followed by Keith to talk more about water level fluctuations. And then we're going to have a regulatory session with DEQ and U.S. Army Corps of Engineers representatives. And we'll kind of break this into two sessions for Q&A too. So if you could hold your questions till the end of the first set of speakers, and then we'll have the Q&A session set up so that you can line up behind the microphone and kind of take one question at a time. We also have Holland TV and DSC TV from Muskegon here recording the proceedings, so we'll need to make sure that we hear your questions, not only for people in the room, but for people who might tune in and hear this later. So with that, I'll hand the microphone over to Mark Breederland, Sea Grant, and he'll provide you with a background on lake levels.
Well, good evening, and thanks for everybody for coming out to this session on Levels 101, and I get a chance to just kind of do a little bit of a warm-up and cover some of the topics, and I think this will be a complementary talk to the one you'll hear next. I'm the educator based in Traverse City for Michigan Sea Grant, so kind of the Manistee area north to the Straits of Mackinac is kind of my first area, but we're doing stuff statewide. This introductory slide was taken in December in East Bay of Grand Traverse Bay. Parts of the Grand Traverse Bays are very shallow, that it drops off really deep in parts of it. But that's where I come from, so we're seeing lots of impacts up our way. So let me mention the kind of an overview of my talk is just a little bit about the system, and you're going to hear a lot more about the system. A little bit about the short-term changes that we need to kind of put in context. What happens on a daily basis. And then I'm just going to give a little flavor about the long-term changes, and you'll be followed up by Keith's talk on the next one, and some talk on some of the implications that we have here with the current water regime that we have. So that's where we're going, and I do always want to start with the kind of the big picture view of the world's Great Lakes and the 21% of our surface freshwater that we have in there, and obviously this is our home. And you saw some of these pictures that my colleague Dan took up at White Lake, so lots of stuff's exposed. I think this is an exposed shipwreck there up at White Lake now, and there's several others. Where is it? This is Grand Haven? Okay, so these other ones are White Lake, because I recognize those. So that one's Grand Haven. But we have several others. Just to show a little flavor, I had put mine in before from Traverse City, so this is much better that you guys would recognize some of these places. And I would encourage you, as you're out and about, levels are still low. Take some pictures. We haven't been this low since 1964. Document, what does it look like? And I think it'll be interesting to kind of look back, because it will be changing through time. obviously lots of different impacts. So let's start here with our Great Lakes and looking at the profile. And I know I've got two screens here, but of course everything, and we're going to start a little bit on the Superior Basin. It's the highest and the deepest of all the Great Lakes, but the area that I'm most interested in is the combined Lake Michigan-Huron watershed. And if you look at the combined areas, it's as far over as Georgian Bay and then all the way down to Chicago. So it's a huge surface area. In fact, if you look at it on a world basis, so this is a table that lists the Earth's 12 highest surface water bodies of water. Now, they're not all 100% fresh water, but if you actually look at it, Lake Michigan-Huron is 45,400 square miles of surface area. Again, all the way from Georgian Bay down to Chicago. So, of course, in true depth and volume of water, Lake Superior wins the race there, but in terms of surface area, this combined lake, meeting at the Straits of Mackinac, is the second largest on the globe. So one of the things that we have to always understand is what happens on a short term, on a daily basis. So this isn't anything that Keith was going to cover, so we felt like this would be a good one to kind of show here. But what happens on a daily basis, depending on storms, depending on pressure. So when we talk about lake levels, it's kind of the undisturbed water level that we're interested in measuring. But on a daily basis, and depending on the system, you can have a wind setup, you can have pressure, and you'll be kind of like looking out there, where did the water go today? But it may be back by noon. So, of course, on the Great Lakes, Lake Erie has the biggest setup at the east-west profile, and it can drop 7 feet there near Monroe and Toledo area. So it's just an amazing. So short-term fluctuations happen. Now, to actually kind of look at the longer-term changes, I have a picture of kind of all of the lake levels and the variation. So I'll just leave this up here for a minute, and I'll point out here on this screen just a little bit the variation. This is all on the same scale. So they're at different heights because obviously Superior is at the top of the watershed. Here's the Michigan-Huron one, and you'll see the changes. These are since 1860. And we had just a few gauges back before 1918, and Keith will talk a little bit about that. But you can see actually on this scale, we have the biggest variation of all the Great Lakes in terms of lake level is the Michigan-Huron system. So you can see Superior is a little bit tighter, and then Lake Ontario actually at the bottom end there is very heavily regulated because of the locks out the St. Lawrence. And at the bottom is kind of the people that are dealing with ocean level rise, and there's this kind of somewhat famous gauge in New York, and there you can just kind of see their small increment of change compared to what we get all the time. So this is actually a picture of what a gauging station looks like. This is the one at Mackinac City. And so there's a number of these around the basin, and there's ones that are agreed upon that we actually get the daily. So there's a kind of a sump down here, and they have the transmittal data. So this is really a nice one right in downtown Mackinac City at the Straits State Harbor. In the old days, the boats used to go across before the Mackinac Bridge from this area. Now, to kind of alleviate the differences in this huge, massive system, these are the agreed upon gauging station locations that measure the lake levels, and then they're all averaged together. So again, way out here in the Georgian Bay at Tobermory, this is up at Thessalon, Mackinac City. We have Ludington's, Milwaukee's, and then this is Harbor Beach on the tip of the thumb. So in the Corps of Engineers, and this is kind of Keith's daily job coming up next, but we get these kind of daily level readings, and you can see there's slight differences as you go from Thessalon back to Harbor Beach, and then they're all averaged out. So when we talk about average levels, it's all kind of taking out the daily fluctuations that do happen. So this is this long-term system. We almost have 100 years of these coordinated data, as it's called, but this goes back to 1918. So very good data record, but yet in terms of geologic time, it isn't that long. Now this is the hydrograph, which goes from 1860 all the way to, this was updated actually a year ago, but the red line is the long-term water average. And these years would have been the yearly averages, so you can see some that were well above that long-term average. and then a number of years that have been down below. And we are at a long term, we're at 14 years where we've been below average without even breaking the average line on Michigan Huron, so I think you're going to hear more from that. Now sometimes those graphs are a little bit hard to kind of just picture, so if you just put it, and I need to get in 2013 here obviously, but if you just kind of look at the red highlighted years, that's the ones that were very low water years, basically from 1860 on. So you can kind of see this is the Dust Bowl era, certainly the early 60s, and then there was a rebound. We'll talk a little bit about that. And then we've been in a big stretch. 2005 was just mentioned because it got a little bit close there, but a big long stretch of very low water years. So that's what we've been actually facing, so that'll give you a different perspective. Now this is a tool that the NOAA is one of the federal agencies that works with the Corps of Engineers on some of the lake level data, and they've got a tool, and I'm going to cover it too again in another slide here, but again the red line is the long-term average. And so if we just took, and we can print different years, so I put 1900 to 2013 on this graph, 1900 to 2013. And I just wanted to kind of, again, identify a segment of time when the lake levels were low. So the Dust Bowl years is 1930 to 1942 or so. And again, you can see that whole stretch down below. And if, again, we look from 1999 to 2013, you'll see the whole stretch here. And this one just barely got. So if you look at 1 year here on this graph, the little blue line is the yearly average for that particular year. This would have been the high month of the year and then the low month. So you can kind of see those bars kind of showing like what was the lowest month, and you can drill down further into this data. But what a lot of people need to kind of think about is the changes that we have. And if you look at that peak, October 1986, and if we look down here at January 2013, there's actually 6 feet 4 inches of difference in terms of that static water level. And some of you are around in 1986 and know some of the tremendous. Think of the large waves and the damage that was happening when you have the water level that high. Versus now we're basically almost 6 feet lower right now than that October 1986 high. So a tremendous amount of variation and different impacts from the wave dynamics at each of those levels, but that is not that long ago, especially in terms of our lifetimes. 1986 reaching kind of an all-time high that's ever been recorded, all the way down to our all-time record low, which was just January 13. So this is a tool that I've used from these graphs, and I'd like to suggest when you guys get a chance to go back to your computer and Google these words, Great Lakes Water Level Dashboard. Great Lakes Water Level Dashboard. And this is the interactive tool that's been put online only about 6 to 8 months ago. And it gives us a chance to drill down to what has happened historically. So what I've actually done on this graph is zoom in to what was our previous record low on the Michigan Huron system, which was in March 1964. And the level then was 576.05 after all those 6 gauges were averaged. And so you can see the yearly average was the blue line here at the bottom. So that was March 1964 was the little dot, and then this was the yearly average for the rest of 1964. So if we look at the next year, 1965, and the following year, 1966, as well as 67, and I didn't take time to put 68, but we're above the long-term average. We're above the red line. So this system rebounded almost in stair steps from its previous record low in 1964. If it will do that again this time is kind of the $100,000 question, which nobody knows. But we can say this for sure. The system has that capacity in a few years to kind of go up at a stair-step level. And sometime when I get a chance, I want to drill down into the 1965 data because it was very interesting. Its peak was actually in September, when typically we peak in June, July, or sometimes August. But 65 looks like some very interesting data to drill down into sometime. So recognize that the variations in time, recognize that even when we were at the previous record low, 3, 4, 5 years later, we were above the average. So we know the system can rebound, and A lot of us are kind of hoping that it will, to alleviate some of the stresses that are on the system right now. So, but that's a tool. You can play with any of the data that's on there, and it's a very interactive tool, and you can put on the otother Great Lakes if you want, or you can just zoom in on Michigan Huron like this one. So I'd encourage your consideration of that. Now I'm just going to give a flavor of some of the information, but when we look at the snow water equivalent up in Lake Superior, and we just went back to 2000 for this, and I didn't put all the slides in, but you can see the reds and the yellows are not good. We really wanted to see the dark blues. When the snow melts, we want them to really get hammered for a good seasonal rise. And then that starts filling up Superior, and then of course it comes down the chain. And so, so really since 2000, if you really look at these snow water equivalents, these are usually flown in March of the year, and they've got a whole statistically valid way of putting together the data. Really, there was one good year basically from 2000 to, I think 2005 was actually a pretty good year. This was 2011. A lot of yellow, again, not real good. 2012 was a little bit better with some greens there, so a little bit of blue over there north of the Sioux. But this is hugely important that we get good system snow impact coming into the system and helping drive the rest of the lakes. So you're going to hear a lot more about evaporation tonight because it's a huge, huge factor in our lake levels. But we really don't have ways to accurately measure evaporation like out over the water. We don't have rain gauges and evaporation gauges. We got a few buoys, but it's really pretty difficult. But there is a place up on Lake Superior where there's actually, this is up at Standard Rock, there's actually some measurements going on that facility out there. So that's going to be a big help, I think, in the future to validate the models that we have for evaporation. So implications, lots of implications with this current low regime, and I'm just going to kind of read off a few, and you guys can think about what impacts that you have seen possibly from the low levels. But one of the things that happens right away is any of the commercial ships have to light load to make it through the system. So light loading of commercial freight, all those costs are actually passed on to all of us, kind of passed on to the system. And you might even get into a situation where there could be availability of goods is not able to be there. So maybe not get your aggregate in or whatnot. So certainly that light loading of commercial freight, and the shipping season has just gotten started in the last few weeks. So obviously they're always looking to light load where the weakest link in the chain is, typically the St. Mary's River. The access loss, this is huge. So I talk about the loss of access into our ports, harbors, marinas, and again, you think of the fixed keel sailboats that are first impacted because they have the most draw, but then it can be power boats and then boat launches. There's been quite a bit of discussion about the challenge with boat launches. I think Dan had a few pictures here. I know there's a few places across the state where they've already been working to extend the concrete out there. It may be easy to launch the boat, but to actually get it back on the trailer, and then your trailer wheels just kind of fall off the back. So there's definitely lots of access loss in this. But when you think about those boats not coming in, that's a huge challenge to our coastal restaurants and our tourism, stuff that really depends on that tourism dollar to come in. So there's another impact across another user group. If you're fortunate enough to own some Lake Michigan Huron shoreline, you have lots and lots of beach. And there can also be maybe some challenge both with changes in the both natural and invasive plants. You think of Phragmites as an invasive. So anyways, the riparians have lots and lots of beach, maybe that they've never seen before that low. So if you owned a private marina, you may be faced with not being able to sell all your slips, or even get access to sometimes potentially even the whole private marina. So, as well as infrastructure damage. So I want to mention infrastructure damage in a few ways here, but you know, fresh water, our cold fresh water does a great job of preserving stuff that's kind of immersed down below. Once it's above water and you have all the bacteria in the sun just doing its damage, there can be tremendous infrastructure damage because of the low water, things being exposed, and sometimes then the wave action on top of that. So obviously we're facing huge dredging needs to be able to get in and out of our places, and thankfully our state has stepped forward in kind of a Band-Aid year and really put, the governor just signed into law about 2 weeks ago, the $21 million to dredge our key harbors of refuge and other spots. So lots of action is going on in dredging right now due to the state stepping in and helping fund that. So just another area, of course, is the whole fisheries area. And so many of the fish species use the nearshore wetlands, and we've had really a rapid decline in the wetlands. So there's a couple different impacts. They can't get to where the wetland plants were, the emergence, and there also can be this kind of disruption from the wave action that would typically there would have been a lot more water to kind of protect where the eggs are, and now that they can be dispersed and disrupted due to the wave action. So there's just a broad brushstroke of some of the impacts that the low water levels are actually having on a whole spectrum of groups. So I want to mention some of the concern that we have actually on our federally owned shore protection structures. Now there's several branches of the Corps of Engineers, as many of you know, but these coastal structures are built and owned by our federal government, and most of these structures have been built between 1860 and 1940. So these are not new, and many of those would have had like a 50-year life design span to it. So I guess our real challenge is that with this low lake levels, we've accelerated the deterioration on these things, because typical construction of these things is these old railroad ties they're kind of called timber crib construction. There's a little bit of a graphic here, shows typically this is wood, and then they put the cement caps on, and lots of rebar and those kinds of things. So these things have been sitting out of the water now for a number of months, taking some ice impacts over this winter. And I would say, as you guys get a chance to look at these, either from the boat side or from potentially walking them, take a picture of them, because the Corps doesn't have boots on the ground in every community. And if you can call in if there's some serious issues, they certainly want to know about it. So obviously they take these huge stresses, and some of you have got some of these kind of great pictures. But there's already, over in Port Washington across the lake, there's some failing structures, Michigan City. So these are all shots courtesy of the Corps that, again, is some potential catastrophic failure of some of the navigation structures. So these things are in dire need of some repair, and yet it's kind of a broken federal funding system right now. So those are some of the challenges. So this is one of those days, and our Sea Grant photographer got a great shot here at Grand Haven. And we have even been impacted by Hurricane Sandy. When that came through here, there was 20-some foot waves out here in southern Lake Michigan. This was taken by a colleague of ours down just north of Port Huron there in Port Sanilac. So again, some tremendous impacts from those kinds of events. So that is basically a little warm-up for the topics, and I appreciate your attention. We will be around for lots of questions and answers, and I'm going to introduce Keith Kompaltowicz from the Corps of Engineers.